the presentation is going to be centered in NLP, but I'm going to keep it very simple for those who don't have particular domain knowledge about NLP, so that we can all catch up and then discuss after the presentation whether we really want to do this project or not. So I'll start with the problem first. So what problem is happening right now is that there are a lot of low resource languages. So what a low resource language is, that a language which does not have a lot of resources such as data sets or tools built around it, and also less people are currently using that language sort of. But with the advent of social media right now, and various apps such as ShareChat and everything in India, these low resource languages are coming into light now, and they are generating a lot more data than they were 2 years ago. And it is really necessary to do something about this data and build tools around it, because if we want to maximize the opportunity and also analyze these languages at a really good scale, the major work right now that is being done in like code mixed languages. So again, the term code mixed languages means that uh, two languages are being fused together. So suppose if I'll give an example again for India. So what we generally do is that we type English. So English is a combination of Hindi and English. So we type the Hindi language using the English letters on WhatsApp or other social media sites. So that is one example of code mixed languages. The other example could be that we are typing in a proper high resource language such as English, and in between we are using Hindi words or any other language words which we might want to communicate better to the other person. So that might be a code mixed language again. The major work that has been currently done is in English and X language. So like English plus some language. So English is Hindi plus English. There are also other languages like Telugu plus English and also others. So, but what happens here is that due to the increasing data being generated by other low resource languages, there are also cases where the two low resource languages are being used as code mixed languages. So like Hindi and Marathi are two languages with a similar script, and sometimes they are used interchangeably in text, and when we try to analyze them, like the native speakers can tell the difference, but the other people cannot, and it becomes difficult to analyze such languages, and not a lot of work has been done in that domain. So I want to explore that particular domain of low resource code mixed data. So like both the node points in the language model would be two low resource languages, and they would be fused together to analyze the code mixed languages. So currently in the field of code mixed languages, some notable work has been done. There is a conference called FIRE 2021, like the FIRE conference, which is held every year. It is famous for like approaches dealing with Indic languages, and they have a sort of competition task going on. Like they have it every year, so which is the Dravidian code mix. So where they select 4 to 5 low resource Indic languages, and then they provide a code mix data set with English again, so that people can analyze and write papers on that. The other notable work in the field is, since these are low resource languages, we don't have data always available for these languages. Like we might have a parallel corpus of only Hindi, and the other parallel corpus would be of only Marathi or any other low resource language. But we might not have code mixed corpus available readily, because these generally don't have that many resources available. So a toolkit was introduced recently, which takes these parallel corpora and it fuses their representations. So in order to create a synthetic code mix dataset. And the other thing that I just wanted to highlight, that people are also doing some character level representations for transfer learning in these code mixed languages. But all of these three recent works are all English plus X low resource language. So again, the low resource part does not get highlighted here. So My proposed solution, sort of, if we work on this project, would be, according to me, would be like generate data using the GCM tool that I just explained, using parallel language corpora, which is available right now due to Wikipedia articles or other resources being generated. Then we use GAN fusion to fuse representations of both of these corpora, and then we extract these representations and use it for a demo task, and then we try to use it like repeat it for multiple language combinations in order to analyze the task. So like, what is GAN fusion? So GAN fusion was introduced recently only by University of Waterloo people. So what they try to do is they try to build a multi-agent. So they take image plus text in order to detect hate
Um,
speech. Yeah,
Sorry,
sorry.
before you jump into GAN fusion, do you have like a slide on GCM for those of us who don't know exactly how code mixing works in like you're saying synthetic code mixing, right? Sorry, you should
Yeah.
come. You're saying synthetic code mixing, but maybe you could sort of jump to an example of exactly what that is.
All right. It was a what I can do is I can just open up the paper here and I can
Yeah, that's fine.
yeah, one second. Yeah. So what they do here is they use two different theories. One is the equivalent constraint theory, and the other is the matrix language theory, to generate all the possible languages. So what you can think of this is like, you build up a matrix with all the possible combinations of mixing. So you have one parallel corpora of, suppose, one language such as English, and the other parallel corpora would be of any language. Let's consider it Spanish for now. And what we want to do is we want to build a code mix data set. So code mix data set means some of the words in that sentence would be English and some of the words would be Spanish. Now, what you want to do is that these words are placed such that they are semantically and syntactically coherent. So first you build a matrix which has like the transliteration knowledge, and after that you build the all the possible combinations that you can of the sentences, and then you use something which is similar to attention in order to extract the most coherent sentence from that, and in that way you try to build your data set. So like, suppose we can say like there's a sentence called I am a boy, and in Spanish it could be something like yo soy el niño or something like that. So now you want to create a code mix data set of that. Then you use that matrix and it will build multiple transliterations of that, and you pick the one which you feel is the most important. So the end result would be something like I am a Nino or something similar to that. So this sentence now becomes code mixed, where some of the part is in English, some is in Spanish, and you can then analyze it so that you don't need to build a data set from scratch with actual code mixed data. So again, they use traditional metrics here, like they use the whole parsing tree and everything, but we don't need to get into details of that. Like, I'll just explain all the basics first, and then we can have a discussion on this in detail later, if that's fine.
I have a question. So when you say code mixed language, is there any formal notion of a code mixed language, or the script is the script always in English, or it can be anything?
No, it can be anything. So so that's what I want to do here. So generally what people do research in is English plus some other low resource language, and then they try to analyze that because that data is more readily available. But code mixed languages can be anything. Like you can take Hindi and Marathi and mix that, and that again becomes another code mixed language text. So yeah,
Okay.
so that's, sorry.
So the code, the fusion of the two language can be in script also, like in the same sentence, some parts are in Hindi and some parts are in English, and well, it,
Yeah, yeah, could
okay.
be. Like, I mean, if you observe Twitter data right now, if you observe like local Indian Twitter data, a lot of times this happens that the some words are actually in that Hindi script and the other words are in like the English script. So this actually happens, like the meaning
Yeah.
and everything is coherent, but the script is different. So that could also be considered as the code mixed language.
Cool. Got it. Thank you.
Yeah. Okay, should I move on, or does anyone have any more questions?
So yeah, just a minute. So in this case, we
Yeah.
are looking at you gave the example of Hindi and Marathi being mixed together. Are you
Yeah.
looking at those written in the Hindi script, which is Devanagari, or both of those written in an English alphabet, and then they are code mixed? However, their meaning is in
So
Hindi and Marathi, respectively.
yeah. So what? Um, so if you look that if Hindi and Marathi is written in the English script, then it would be sort of uh, like a mixture of three languages, right? Like English plus Hindi plus Marathi. You use English for the script and the both of the others for the semantic meaning, sort of. So
Okay.
yeah, I what I'm trying to propose here is low resource plus low resource. So like in Hindi script, if we are mixing Marathi, but again, I also want to consider other multiple language combinations. So like there was a suggestion that we should also look beyond Indian languages. Like sometimes there are other Asian languages which might be mixed, like not just with Indic languages but with each other too. So I also want to look at that. Uh, so what I'm trying to propose here is a basic framework, and then we can decide on the languages as we move on, sort of.
Right. Got it.
Yeah. So the proposed solution here is using GAN Fusion. So what GAN Fusion in GAN Fusion, what they did was there is a data set called MMHS 150K, in which there are images, and then there is a caption text of those images, which depicts some sort of hate speech, and they try to extract the features from the images and also from the text, and they wanted to create a fused representations of both of them in order to detect if hate speech is present in them or not. So what they did was they created two GANs, and they and then they first created these two vectors, as we can see here, the ZB and ZT vector, and then using both of the GANs, they tried to fuse the representations. So the input to one GAN would be the main vector that we are trying to consider. So this is the vision GAN here that they considered, ZB, and this is the text GAN here that they considered. And this dotted line here is the meta features that you are supplying of the other thing. So in our case, both of these would be textual representations, right? So I'll just explain what the features were and how, and then we can come back to this again, like how they are fused. So in order to form these Z vectors, what they did for text was they cleaned the text using a tool called Expresses, which is generally used to clean social media text. And after that, they did POS tagging to create some metadata of the text, which was in the form of tuples. So like subject, object, verb, and modifier to create a pointer, which was called PT. And this pointer PT was passed through a general LSTM model, which was then accompanied by a word attention module in order to create the input vector ZT. So this was the input representation ZT to the first GAN. And the vision one, since we are not going to do any images, I won't explain that. But what we this ZT would be the main representation ZT, which is formed after the LSTM, and the dotted line you can consider as the PT being passed here, just so you get a semantic structure in order to create a proper output vector so that you can fuse it later. Was this too much, or like I didn't explain it well, or like what was it? Does anyone have queries?
Makes sense to me. Can you just explain it again? What Z fuse is? So like what the
Yeah, yeah,
output represents?
yeah. So the output to one GAN would be, so like again, let's consider Hindi and Marathi here. The red one is Hindi and green one is Marathi. So the output here would be like some Marathi representation, sorry, Hindi representation, and this would be Marathi representation. And then we pass it to like a fully connected feed forward network. And Z fuse is the combined representation of both the languages. So what I am proposing is that we take these combined representations and use it as an encoder for a language model to see how well it can generate the code mix data, so that we can use it for the other classification or other necessary tasks.
Yeah,
Does
no,
that?
yeah.
Yeah.
My question was in this specific paper where one is image and other is text.
Yeah.
What are they trying to predict here in this
So
case?
they are trying to detect if a particular image and caption pertain to some sort of hate speech or not. So later what they do is they take this Z fuse and then they use it as an encoder in a word classifier. Sorry, not you can use it in as an encoder for any classifier, and then they try to predict if a particular social media image plus text is pertains to hate speech or not. So they consider this as sort of a multi-model approach to online hate speech detection. And so we can use the same thing to detect like code mix text and also conduct various analyses for the same.
Got it. Wait. So
Yeah.
uh, let's say one ZV represents one language, ZT represents other language.
Yeah.
So are we generating the code mix language, or I did
So
not get the last part.
So, like, I mean, I thought that so if we use this as an encoder, then what we can do is we can either put it in the back of a classifier to generate some sort of classifier task, or like we can try to build a language model first in order to generate the code mixed language properly. So, like, use this encoder and then fine tune the synthetic data set that we created earlier. So that we created here using GCM, and then see how well we can generate code mixed language. Because if we are able to generate the code mixed language well, then we can also use that encoder for other tasks. If we consider sentiment analysis or anything other than that, like next sentence prediction or whatever we want to do, question answering too.
Yeah. Got it. Thanks.
Yeah. I mean, this can also be extended to accents in like the same language. So if we observe, then even Marathi has like 7, 8 different types of dialects. So we can transfer this to that research too, so that like you can build technology actually for the people living in rural areas, such as chatbots or something, which may understand coherently what they are trying to convey.
So, a question, is there a prerequisite to understand the rules of semantics in this language in order to generate some sort of synthetic data that relates to that language?
Um, I think yes, because like we would need to know like how coherent the data is. I mean, we can start with the languages that we know properly a bit, and then we can we can have other people evaluate it, sort of. I mean, the people who are familiar with the language.
Yeah, I think what I was getting at was like, what are the bottlenecks for, say, you have a new low resource language? What are the pain points in this workflow that you need to spend the most effort on?
I think the major pain point would be what you mentioned, like the expert annotator that you might need who can evaluate it better. Like some languages and scripts we might not be familiar with at all. So we might need someone to evaluate it properly. So that might be a possible bottleneck to the project.
Fair enough.
Yeah, I mean, the impact was something which I discussed already. The major thing that I would like to highlight is the computational social science tasks. As I mentioned, like you can build projects actually for rural areas, and you can have like introduce technology in their own dialect without like a lot of effort if we build good encoders using this. And the future tasks may also include like probing these already built models for some learned biases, because like as we know, language is always going to have some theoretical bias already present in the data set. So it would be really exciting to build actual like probing mechanisms for low resource languages, because we don't have that at all right now. So yeah, that was it from my side. Does anyone have any questions? like also regarding the viability of the process.
That was really good presentation. My question, maybe I should have raised this much earlier, but if I understand correctly, code mixing also involves script mixing, or is it just one script?
So code mixing can have script mixing. Like I think Gaurang asked that question. Fennel also raised the same question. That like suppose we try to mix Hindi and English, then would that Hindi word be as it is in the sentence, or like would it be converted to the English letter and be in the sentence? So it can be of both types. Like, and we would need to recognize it. But if it is in its own native script, then it would become a bit easier because there are already tools to identify like what script is it based in, not the actual language. We won't be able to do that really well, but still there are tools to identify the script which is like which it is based in.
Can you switch back to the can fusion right now?
Yeah, sure.
Yeah, so again, I understood the task and what we are supposed to do, but at the granularity level, I still can you walk us through some example? Let's say one text that we have is I am a boy, and other text that we have is मैं लड़का हूँ in Hindi script, and other is in English. And let's say we output we pass it through this GAN fusion network, and we get this Z vector that is a mixed representation of both of our input text. And
Right.
so what is our task after with this Z vector? Are we generating the code mixed language which would output something like मैं boy हूँ, or is that the task that we are going for?
So the major task would be that it should be able to generate that really well. I mean, the data set that we would form, it would be using the GCM technique that I mentioned. But then what we want to do is like this Z fuse that comes out would be a combined representation of both the languages, right? And
Yeah.
then if we try to fine tune the GCM data set on this encoder, like try to build a language model and then fine tune these representations, then we might be able to build a better code mixed language model. And then we can use that for a set of demo tasks, sort of like we can decide on various tasks that we can conduct on the same. Again, the tasks that we do would have the bottleneck of some expert annotators to build a proper data set.
I get that. Like, let's say we want to like generate this sort of field representation, but if we see, if let's say we have two different tasks, right? Like, how we will be evaluating whether this representation that we obtain is good enough or not. So like basically the underlying objective or the task, like what exactly we are trying to do. Because if we see this both of them are like individually like of its own, right? Let's say we train a language model to do something for two different languages first, we put it together, we get some representation, but how do you evaluate whether this representation is good enough or not?
Yeah, so that's why I mentioned that we could try building a language model first. Like we take this representation, we fine tune it on the GCM data set, and then we evaluate it using some preset metrics like the blue score. I mean, I know the blue score is not very reliable.
No, no,
But,
like, so like the point being is, let's say we have TCM tool right now, suppose we have like we are thinking of like this, let's say like suppose red and green as two different languages, suppose right now at the moment. And what we are trying to do is we get this representation and this representation two different languages. We are trying to fuse, suppose. But like if we think of like let's say we have one language model for one language, the other language model for let's say green one, we like do it forward pass suppose. But what is the objective against we are evaluating, right? Because combined representation, how do you evaluate? What I'm trying to say is because the objective should be something common, right? like where the loss should propagate both were valid, right? Like how do you validate that the representation obtained is good, because we need some objective as well, right, on that side.
Like, so you're saying that the Z fuse, how do you evaluate if the Z fuse obtained is proper or not? Is that your question?
Yeah, yeah. Yeah, because like currently if we see we take two different language models, we train like end to end, we get let's say this visual representation, but how do we evaluate and like
So I think we dropped off there.
So till then, like I maybe missed something. Our output is going to be a code mixed sentence, right?
Yes.
And
For
for that,
Z,
right?
yeah. Sorry.
And for that, are we giving the input as the whole? Okay, fine. Go on.
yeah, sorry, I got disconnected. Hello.
Yeah. So
Yeah. So did you understand?
yeah,
Yeah.
but wouldn't the
Yeah.
evaluation function present in the individual grants suffice that requirement? And I think we are also pre-training. Like this would sort of be
No,
like
like
pre-training.
let's say trying to like suppose let's say in translation, suppose that we are doing right, like this paper that it presents. So here, suppose let's say it's for online hate detection, suppose. So then there is something right, like the label or something which like leads or like at least gives signal whether like this field representation that we are learning is good or not. Right, and like based on that representation, it then further propagates the signals. But here, let's say we know like what we want to learn, like that is why goal is like learning this good fuse representation. But where are we using this fuse representation further for something where from where we can get like this backward signals, like right?
Yeah. So that's what I mentioned. So we use this fused representations to fine tune on the GCM dataset, and then we train a language model like that so that we can evaluate like whatever is being predicted. Is that what you're saying, or
Oh,
you're asking
so
me
you are
how do
saying that you will,
yeah, sorry.
yeah, just so here, like we'll have two different language models, like or how is it?
No, we won't have two different language
Could you
models.
walk through like GCM dataset once, like how it is? So is it
GC,
like we have X, Y pairs or like
GCM dataset would just be a text corpus which would contain code mix data. There would not be X or Y pairs. The input to that method would be two separate monolingual corpora. So, like one would be suppose Hindi, the other would be Marathi, and the output you can consider is a whole corpora, like a whole document dump sort of, which contains code mix sentences. And then you would take that as your like source text for the code mixed language model that we are trying to produce. And in that code mixed language model, the encoder representation we would consider as the Z fusion, which is the output from here. And then we would fine tune that whole thing on the GCM dataset, and the output of that would be evaluated, like how well it can produce code mix data. Because if it produces the code mix data well, then I think we can transfer it to other tasks and also like perform other tasks well too.
makes sense? But in this case, like probably like it is more like let's say you get this representation like where you use this parallel monolingual corpus and the other is code mix or trying to align the embeddings close together using contrast reloading or something like that, right? Then if I get this thing correct.
So that thing I propose that we do it using GCM. So like that is a toolkit that they have developed. I mean, if you want, then we can also try to explore how contrastive learning would work. But what they try to do is
Because
parser thing, and then they try to produce all the possibilities of text, and then they mix that completely. So I think, yeah, you can see here. I
because
think this is a proper example.
yeah. Yeah, because like the problem is if let's say we have longer textual sentences and like there can be more than one possibilities, and in order to evaluate over all these like there can be more than one ways, right? Basically the model can produce same text, and
Yeah,
which
yeah,
is why like I thought like contrast to learning might be better, where we just try to say okay, like let's say if this is not similar, then we try to push it more and more away from the embeddings. If this is similar, then we just
so
like align the embeddings to be very similar, something like that.
yeah, I think what you mean is this, right? I mean, these all are coherent in meaning. If you can see my cursor in figure 5 here on the paper. So these are all really coherent, but you need to choose which is the more natural one here. So I think they have taken care of that too.
Okay.
Yeah. So like, yeah,
I
we
think
can discuss on contrastive learning definitely, but yeah, I think they have taken care of that too. So they don't try to align the embeddings for this.
okay, got it.
Gaurang, you had a question
Yeah,
there?
yeah, I got my question answered while you were explaining this. The input is the same sentence in the two languages that we are using, right? The
Yes.
whole sentence, yeah.
Yeah, yeah, yeah. If you see this.
So we are essentially stacking up two networks. One is GAN fusion, and then some other language model that generates a mixed
Yeah.
language, and then we are training it end to end. Correct?
Yeah. Exactly.
And so the question I would have is, so between that stacking, there is also human verification that the first model actually generating coherent code mixed languages, right?
Yes. I think that would be the output of GCM, right? What you're trying to refer.
Yeah.
Yeah. Yeah.
So
So we
the
are
reason,
not. So the GCM thing would be different. The GCM would just get you the required data set that you want to feed to your language model, and the other phase would be stacking this GAN fusion onto another language model, which would take the input as the GCM output. So that verification phase would be in the GCM output part.
yeah, thank you for clarifying that. That's important. My question was more like practical in terms of, if you're saying this is a Unicode research project, then you want us to work on Hindi, or is there a specific regional language you think we should work on?
So like I am open to work on any language. I mean, I would prefer working on the ones that I know, but like I'm fine with any that everyone is comfortable with. Right? We also have people who don't know Hindi, right? So our depends on
Yeah.
Hindi.
Yeah.
So yeah, we can take a poll on that. I'm fine with it.
Yeah. So I just want to raise a couple of concerns for this project. So one is we are essentially training a new language model from scratch, and that would require a lot of compute plus lot of parallel data. Because I don't think we can use some pre-trained language model, because the thing that we are feeding is some Z vector and not some text to this language model, and even what we are generating uh, is something else entirely. And our generation also, I'm concerned, if it's a language model, then how would the vocabulary be like? Will it will it contain the entire vocab of just English text, and let's say we are just considering English and Hindi for now. So English text and Hindi text, or will it also contain words like maine, where maine, where the script is in English, but the word essentially means my in Hindi, and so will we and the same word can be written in multiple ways, because there is no formal notion of how you write Hindi words in English script. So will the vocabulary also contain all of those words? So yeah, these I'm not clear about these things in the language model part, the second model part, while we are generating this code mixed language.
an honest answer to your vocab question would be that I have not thought about that. Like we can do subword embeddings too. Like that would also be a possibility, and then you would have various things connecting to each other. Like so, I've not really gone over that vocabulary part, so we can discuss that further. I mean, like we have like if we want to do this project, then we can have a discussion regarding that. And yeah, regarding the compute thing, that would also present a possible issue. So yeah.
Yeah, fair enough. Thanks. And the amount of data also, I'm not sure how big the GCM data is. Do we have an idea how big, how large the corpus is, the GCM data set that will be training it on?
What we can do is we can consider Wikipedia articles if we try to start in the beginning. So if we consider like the ULM fit method that they try to do, what they do is like they take like around 15 to 18,000 articles on a particular language, and then they try to train that. So we could also try to mine around the same set of articles, but again, the size of every article would differ. So we would also need to look at that. But I think 15,000 articles per language would be a pretty safe bet if you consider that.
True. Yeah. Okay. Makes sense.
Yeah, and also regarding your parallel corpora question, so United Nations has released a lot of data like monolingual parallel corpora, so we could also use that. Yeah, because we would need the data to be parallel here. So yeah, definitely.
Got it. Thanks.
Does anyone have any other questions?
Might be a stupid question. Parallel corpora is basically the same sentence in two languages, right? That's
Yeah,
what...
yeah, parallel.
All right, if that's it, I can stop the recording if there are no more questions.
Yeah, stop sharing.
All right, thank you.